Thank you, Yaroslav, for introduction, and thank you everyone who came today. And also, I'm really glad to be a speaker today and be a part of AI Week in Belgrade. So yes, as Yaroslav also mentioned, agents is really a hot topic nowadays, and everybody tries to build its own agents, both in scenarios when you have to build them and in business scenarios when you actually don't have to build them. So today I want to share my experience, research, and insights from the conversation with businesses I have about agents, how to build them, whether in what situations they're actually useful. And just about a few seconds about me. So I'm a machine learning engineer at Raw Ventures, a London-based VC fund. We invest in health tech, media tech, startups, and sustainability. And there I also help startups with hands-on ML expertise, advise on internal policies, and actually look at tons of AI startup pitches. Before that, I worked at Abbey, and in my free time, I like to contribute into open source, playing video games and other stuff. So yeah, for the last 2-3 years since ChatGPT release, we have seen a lot of good engineering practices that arise in real business application, starting from single LLM features when it was really amazing to ask GPT summarize text or extract valuable information from it. Then we learn how to orchestrate multiple LLMs calls in order to solve more complex tasks that allow businesses and whole new categories of products to arise. And today we came to agents that actually autonomous LLM-driven systems that equipped with tools in order to achieve and solve complex end-to-end tasks. But the problem with the agents that it's a double-edged sword, because on one side, agents allow you to query APIs, write code, draft reports, and do really complex stuff, required reasoning and have an understanding of your tools. But on the other side, agents share the same fundamental problems, but that LLMs has and other large models, magnified by the degree of the autonomy of the system. And these problems include hallucinations that are probably not going away as far as I'm aware by the recent research. But with agents, it's far worse because you have a compounding errors that accumulate over multi-agentic turns when they try to accomplish the task. Because if your AI system performs a task with, for example, even 95% of accuracy, then if you scale it by multi-turns and its own reasoning, if it does a mistake on a certain step, this mistake leads to probably another mistake and so on. Everything like with humans. As an example, I really encourage you to go to Microsoft's Net Framework GitHub repository and look how Microsoft developers are actually being driven crazy working with the latest GitHub Copilot, performing whole tasks on their own. The other problem with AI agents that also persists in common and more traditional LLM systems is safety problems. Recently, I was able to find a pretty interesting injection called toxic agent flow discovered by Invariant Labs that do evaluation, safety, and other LLM-related research on that topic. And they actually found out that in a setup where LLMs have access to a public repository and a private repository, if an issue described in a public repository really has an injection that prompts agent to go to private repository and extract code from it into README file and publish it in a public repository, it will actually do. This Last thing that's also common for many LLM applications is a lack of evaluations. And another problem with evaluations that in case of agents it's really harder to do because you have to evaluate not only the final output, you have to evaluate the reasoning step, the action it takes, and also you have unbounding costs and many problems associated with that. So up to this point I've talked about problems and what agents are. Now I want to focus on a few things like choosing the right problem, then move to a topic to discuss workflow, or the difference between workflows and agents and where each thing is more preferable, and at last talk about how to design normal and working agents. So the first thing, we have to think about the problem, and in order to do that we have to understand both both advantages and disadvantages of AI and humans. In short, AIs are really better and faster at processing tons of information that we can never do in a reasonable time with our human biological brain. But on the other side, humans are really creative and really capable in finding problems and logic reasoning. So if we combine these two, we will actually benefit for any AI product or AI-based system. So the second important step about problems, you have to focus on the right business problems and real business challenges, because sometimes what I see in a lot of AI startups, they try to pursue the goal of targeting current generation of models' weaknesses that will be easily done in the future by top frontier AI labs like OpenAI, Anthropic, and so on. So talking about the problems, you also have to formulate it right, because usually business gives you a formulation like this. So sales team are not closing enough deals. The problem with that formulation that you actually don't know how to address the problem, and secondly, you don't know how to quantify the result, so you will later be able to measure before and after effect. And your task as AI engineer to identify in the conversations, in the research, and formulate a right problem, like giving it quantifiable result and understanding what actually causes the problem, so you will be able to address it. Good examples of AI startups I saw that target real-world problems is Scope. It's a startup that addresses really boring thing. It helps both businesses and inspection to speed things up in order to better process data, prepare for the reviews and other things like that. And well, that's one example. Second example is Valence, who designed an AI coach. It's a more specialized LLM that helps people in their work environments to mitigate possible problems, burnouts. And its competitive mode is really cool because they have understanding of the area. They invited special coaches that invented the methodology in order to guide the agent. And yeah, moving from the business problem to technical definition, how to approach it. There's already established pattern that proved to be useful in many AI products called workflows. Anthropic writes a lot about them and actually values them really and advises to use them more and more if you can in situation where you have to choose between agent and workflow. So essentially workflow is a way to connect different LLMs or LLM calls in order to solve particular problem that could be well written as a process, step by step. So then you have a lot of different options how to do it, starting from prompt chaining, where the output of the previous model goes to the next step, parallelize and everything. So first of all, really it's valuable to break down the whole process. And if you can do some sort of simple LLM call, or you can arrange it as a pipeline, then it's probably the best solution, because you can rely on that and easily debug, find where the model produced an error. So the first, try the simplest solution. If it's not working, then you can consider building AI agents, keeping in mind real advantages and benefits that AI agent brings to your task. So agents actually work really well, from my experience, with some sort of creative tasks and exploratory tasks, when you have to do data analysis or process tons of information on the web. And yeah. Also, it's very useful in situations when you don't have strict decision making and you have to work on different corner cases. It's so for example, in customer support, it's quite valuable, and some things like that. So moving to actually talking about agents. Agents have three main components. It's a model and context, then it has tools, then it has guardrails. The first, let's talk about model and context. It's a graph from State of AI Agents report by LangChain, when they queried their customers what problems they experience building AI agents, what do they found, what not. And the thing is that they found that in 41% of cases, clients actually struggle with models' performance. And when they started the investigation deeper, they found actually two reasons. The first one is that this model is not good enough. The second one is that the wrong or incomplete business context was passed to the model. And usually, with the current state of models, the first one is not the problem you have to pursue. You have to pursue the second one. Fully understanding the problem and being able to give model instructions to break down the problems and feed right data chunks. As the research by Adobe suggests, that there's a popular benchmark called needle in a haystack. So they actually explored the limitations of this benchmark and found out that many models that claim they can process many tokens, like millions of tokens, they actually in real situations struggle with more than 8,000 tokens, even the best performing one. So what this graph actually tells you, that your instructions have to be clear, and you have to you teach your agent to break down the task into smaller pieces in order to navigate more freely and in the right, correct way. So yeah, give the clear instructions and the right context to agents. The second one is tools, and as OpenAI suggests, you have three categories of tools. The first one is data, or tools that allow model to gather records from CRM, databases, search PDFs and everything else. Then you have action tools that allow to send an email or do some action. The last, what they call orchestration tools, where agent itself can be used by another agent as the tool. It's a more complicated approach, but we still will talk about it. The thing is, you have to always think about the tools that each tool will have an unambitious description, and you have to avoid tool overload. By tool overload, I mean when agent has so many different tools and sometimes overlapping tools that leads to agent not able to decide what a particular tool will be appropriate for the next step. And a good example of defining tools is the autonomous agent by OpenAI called Codex. Because if you look at what actually Codex does inside, it has two actions that is able to perform. The first one is use terminal. The second one is to edit files. It doesn't have functions like use git, use bash, or something like that, and it doesn't have many different tools that tell him to use particular Python or Java or C++, I don't know, whatever possible. Instead, it just knows how to execute commands and operate with the files, and it's really enough. So moving forward, with orchestration, still, if you define clear instructions and define normal set of tools, over the time that your agent is being developed, your instruction will become larger, and there will become more and more tools dependent on business scenarios. So this actually will lead your agent being mind blown, and that is the exact situation when you have to think about splitting your agent into more specialized agents that are able to either communicate with the mother agent or father agent, whatever you call it, or the agent orchestrator will be able to use them as tools and execute and ask a particular agent to perform an action in a given step. For example, you have a system that is able to search scientific articles, review them, and write summaries. So this will be the agent orchestrator, this will be a research agent, that will be a writer agent, and that agent will be able to delegate the task to the first one, to the second, and aggregate the results. Yeah, that's all the orchestration. Then we have guardrails, and guardrails actually are an important thing because it prevents both you and user from the unsafe situations, like for example giving your customers data or processing invalid input. In this example, researchers were able to prompt jack and hijack the Anthropic latest Opus 4 agents just in under 4 hours to provide the recipe for biological weapon called weaponized gas called zarine. And in this case, not thinking about guardrails could lead to a reputational risk or really potential really threatening ones. Or as the second example I want to show, that in 2024, a guy was able to prompt ChatGPT assisted bot on Chevrolet's side in order to get a huge 99% discount on a car and be able to buy that for $1. So that if you're a business, you actually don't want to end up in such situation. So guardrails could be of two types. The first one is an input type. The second one is the output type, when you evaluate the LLM response for toxicity, hallucinations, or try to detect data leakage. The same applies to input, when you have to check for prompt injections, forbidden inputs, like, I don't know, asking the same about biological weapons or use cases like that. And essentially, guardrail could be a small classifier that is able to detect 0, 1, or multi-class categorization for users' input, or it could be an LLM itself trained for more nuanced situations. And the fourth one is what I call triple E rule. It's evaluations, evaluations, and evaluations. So as I said previously, evaluating agents is not the same as evaluating LLMs, and I won't repeat the same slide twice. More I want to focus on the thing that is really important for the business. So people, especially researchers, when thinking about business applications, they mess two definitions. The first one is capability. And the capability tells you that if the score has some sort of pass k, that it means that one of k answers model has given was correct. And that's actually good in research situations because you don't have to think about reliability when your agent has to consistently work with the given accuracy. And that's the main problem that I encountered many times in working in a VC fund or working with other people. Making agents constantly work and delivering the same expected result is actually much harder than anyone can expect. And talking about examples when people actually did wrong evaluations and what it can give us. So the first example is Do Not Pay. It's a startup that actually told people that it can replace lawyers to draft every document they need, any court claim and everything else. But what they actually missed, they missed evaluations completely, because when they deployed this product to the customers, they quickly figured it out, customers, that the system doesn't deliver what was promised because drafts were absolutely awful and not suitable for the level authors claimed it to be. And later, Federal Trade Commission of USA started an investigation when they came to the conclusion that this startup absolutely did not any evaluation of their product and their system, and more importantly, they didn't invite even a single expert that has experience as a lawyer and who can advise them on that. The last example is pretty funny because it's not about the evaluations, pure numbers. It's about the problems that agents can bring you even with even on the evaluation stage. Because at some point in February, Sakana AI, it's a Japanese AI library sponsored by NVIDIA and other serious market players. So they claim that they designed AI CUDA engineer that is able to design CUDA kernels that give you up to 100 times performance gains on machine learning for deep learning tasks. But it later pretty quickly was figured out that actual results are up to 3 times worse than they claimed. So the overall system performs 3 times worse than without it. And when Sakana started its investigation, they were able to figure out that because system had an access to evaluation code, it pretty quickly figured out that if a ways to cheat the evaluation system and by that mitigate and make up the results. So that's an important thing, to also carefully design your evaluations in order to be sure that agents performs what you intended to do. And that's a reason why I told that you have to not only evaluate the final output, you have to evaluate also the reasoning trace and steps it take. So the final things I want to summarize from my talk, that first of all, we need to identify the right business goals or industry problems. Then, even if we want to build agents, we don't have to rush to build them if we can create a simpler solution that will deliver the same and more verifiable results. And the last thing, that even if you decided to create an agent, you have to think about maintaining the simplicity, and that's it, probably.
Thank you.
Yep. Mm-hmm.
You talked through an example where someone was able to hijack Claude to produce the recipe for Zarin.
Yeah.
The question is, do you happen to know if it was like real recipe, practical recipe, or just general or hallucinated answer? Because the general recipe is actually available on Wikipedia. So I think this is like two different types of problems where one problem is that Claude is potentially able to give some
No. I mean, Claude was really able to deliver the recipe that you can actually use. And as far as I remember, the researcher who found this also checked this out with the experts in biology. Secondly, Anthropic themselves in the system card claim that they even raised their internal security checks because they found out that Opus 4 is actually pretty, I would say, well in crafting recipes for bioweapons and biohazards.
Wow, that is really alarming. Then you need like real experts to verify all this, and I think.
In my opinion, the first and obvious thing you have to do if you work under some business application, you have to attract and consult domain experts because they will able to give you real practical insights that will save you tons of time in order to create a product people will actually use, either it be more simple LLM workflow or AI agent. Yeah. Mm-hmm.
You mentioned reliability on one of your slides and said that you'd expect an AI agent to be like idempotent or functional in terms of expecting the same output each time you feed the same input. Do you believe it's feasible at all when it comes to AI agents, given that they are non-deterministic?
That's a good question, and I actually believe that it's it's both advantage and disadvantage at the same time of this particular tool. We call LLMs or visual language models, whatever it can be. The probabilistic nature really defines that you probably won't have the same output twice or three times and more and more and more. So in the future, I don't believe that agents will be able to consistently perform the same output based on the same input. But the thing is that instead of that, I believe that we have to better think about use cases where this limitation and advantage will be really beneficial. Because in my opinion, this use case is really beneficial when, AI agents and this sort of hallucination, not ability to produce deterministic outputs will be really useful in prototyping or delivering quick experiments. When you want to iterate on a product design, for example, you generate 4 or 5 iterations, decide what's best for you, and then you go. So, and that's probably what any deterministic system won't be able to deliver. So yeah, we just have to separate use cases, both for deterministic systems and both for agents, and they probably won't be the same. I remember probably you had the question, yeah.
So on a couple of slides, there was a dilemma, like make one call for LLM against build some system with different agents, which calls one to other. But for me, it's not clear about this dilemma because we have also like reasoning models, which has different calls inside, where we wanted to put it. And another is like long chain models, which use the calls during tracing during one call, like LLM, but it is do some sub-queries during this call, can go somewhere and get information from outside. So where we wanted to put that, and like to question. What do you think about MCP, this modern stuff from Anthropic to agents to communicate?
Yeah, if I could ask you to probably finalize the first question because I didn't get it. Yeah.
This dilemma of one model versus several agents, where you put reasoning models and where you put long chain stuff.
Reasoning models actually could be also integrated with within the workflow pipeline, but the thing that allows us to use them, I would say, with more degree of in a more deterministic way, is to design, I would say, a plan that will allow agent to allow reasoning model to think step by step and formulate it as a chain of thought in structured output pattern. It's if someone doesn't know about it, I really refer you to a Telegram channel called LLM Under the Hood, and course by Renat Abdullah, who actually explains that thing. So you still can write it down and use to trace reasoning steps and to correct it. So it doesn't exclude each concept and doesn't allow to exist simultaneously, yeah, but still my point was more about thinking from the business perspective, because if you say that, okay, to the business, and that's what I hear mostly, that people want to understand what the system does on each step, and they want some sort of reliability, and that's why agent is sometimes not useful in this case, because you really will spend a lot of time trying to understand what caused this problem and so on. And about MCP, let's say that, in my opinion, MCP is, I think it's a great tool for AI agents. The only problem I have with MCP that many safety specialists, and by that I mean cybersecurity, complain a lot about vulnerabilities in the MCP design that will lead to a lot of problems. Actually, that's a common pitfall for many AI systems. If you talk with cybersecurity specialists in many companies, they are really, really afraid and don't know how to mitigate the effects that system cause, and it causes them a lot of pain to do so.
You have time for one more quick question.
Yeah.
I would like to learn more about multi-agent systems. So I heard that some people to get dozens or even hundreds of agents to work on some task. Is there any successes in this agent populations, as they call it, or does it too experimental for now?
Well, if we talk about Twitter AI experts, yeah, they really able to do impressive things. In my opinion, unfortunately, and from my experience, I sometimes struggle even with a simple one agent to do the thing I actually want to do, and it's usually connected with coding. So yeah, I even don't want to trust the system that autonomously do 1,000 tasks in parallel, yeah, because an example of that is actually a Manus. My problem with Manus AI, that is a general AI agent, that the time it spends on task completion is so long, and the amount of action it does so long, that I don't have time to verify everything it completed for me. And that's the problem, because, for example, if I will take Manus and ask him, oh, please prepare me a report about successful AI startups, and it will work, for example, for 30 minutes, compose me a beautiful landing using a website and web hosting, and I will bring it to my manager. So if my manager will ask me something about this report and I won't be able to answer, well, I'll be in trouble. And in this scenario, this agent doesn't save me any time because I have to verify the output. So I better prefer copilots when I can guide them, or even agents that can do a draft for me, then I will work on later, but still I will spend some time on it.